My name is Aubrey Arrington from Dr. Zaval's Chemistry 108 class. Today I will be teaching how energy content is determined when there is a temperature change. Learning this, you will be able to calculate the amount of energy released through the burning of food and fuel. First and foremost, it is important to know the letters that each one represents in the formula. Here we have Q. Q is the energy added or removed from a substance through heat. S is the specific heat. It is 1.000 lowercase cal per grams degrees Celsius. M is the mass. Here we'll be using grams. And delta T is the final temperature minus the initial temperature. It is important to make sure that all of your given labels coordinate with each other. If not, it is important that these numbers are converted before moving forward with the formula. Being that mass can be given in kilograms, so that the Celsius would have to be converted to kelvins. Now that we have determined what each letter symbolizes, our formula given is Q equals S times M times delta T. So a real-life example I have here is how much energy is required to raise 125 grams of water from 22 degrees Celsius to 43.2 degrees Celsius. The first thing I'd like to do is pull out all of the numbers needed for the equation. Since we don't have a Q, which is the energy, I put a question mark next to it. The specific heat here is 1.000 lowercase cal per grams degrees Celsius, and our mass is 125 grams. The delta T is represented through 43.2 degrees Celsius minus 22.0 degrees Celsius, which will result in us getting 21.2 degrees Celsius. Now, with the equation, or formula I should say, used earlier, we will place all of these numbers into it and then solve. So Q equals 1.000 lowercase cal per grams degrees Celsius times 125 grams times 21.2 degrees Celsius, which will result in the energy, also known as Q, equaling out to 2,650. So another real-life example I have here is how much energy is required to be added to 7.00 grams of water that is initially at 37.0 degrees Celsius in order to raise the temperature to 65.0 degrees Celsius. Now, as before, I like to pull out each of the numbers and place them in to their correct formatting. Q, we need to figure that out, so of course we put a question mark again. S, the specific heat, we have 1.000 lowercase cal per gram degrees Celsius. And for the mass, we have 7.00 grams. And for the temperature, we have delta T equals 65.0 degrees Celsius minus 37.0 degrees Celsius, which equals 28.0 degrees Celsius. Now, with all of these numbers presented, we will plug them into the formula. So we get Q equals 1.000 lowercase cal per grams degrees Celsius times 7.00 grams times 28.0 degrees Celsius. Now, we will multiply all of these numbers and get Q equals 196 calories. Now that I have taught you how to determine the energy content when there is a temperature change, I hope you will be able to apply this knowledge to future Chemistry 108 questions. I'm Aubrey Arrington, and I hope that this helped you out.